This video is a continuation of the series of problems I've been working on trigonometry, double angles, special angles, and so on and so forth. To see one of them, just click on the link at the top right corner of your screen. Now, here I would be expressing sums and differences as products. In the video on double angles, I started off with these formulas. Here are the 6 formulas. Now, in expressing sums and differences as products, all I'm going to have to do is add and subtract some of these formulas. For example, to obtain the first product, let's add equations 1 and 2. So we've got sine A plus B and sine A minus B on the left side. So adding that fetches me sine A plus B, then the plus, then sine A minus B, sine A minus B, equal to, now adding the right side, I've got sine A cos B plus cos A sine B, then plus sine A cos B minus cos A sine B. So clearly, if we add these two, we would find that sine A cos B plus sine A cos B would give 2 sine A cos B, and cos A sine B plus then minus cos A sine B. Since plus minus is minus, so it's obvious that cos A sine B minus cos A sine B would become 0. This is the first product. 2 sine A cos B is equal to sine A plus B within brackets plus sine A minus B within brackets. And we found this by adding equations 1 and 2. We can do the same for equations 3 and 4. If we add equations 3 and 4 right here, this is equation 3, cos A plus B, and equation 4, cos A minus B. If I choose to add, then the left side is going to give cos A plus B within parentheses, then the plus sign, then cos A minus B, cos A minus B. Now this is cos A cos B plus cos A cos B. That becomes 2 cos A cos B. Similarly, I've got minus sine A sine B plus that's a plus, sine A sine B. So we can see that this is going to vanish. It's going to become 0 because minus sine A sine B plus sine A sine B is 0. So this is the second product. We can see 2 cos A cos B is a product, and it's equal to cos A plus B plus cos A minus B. I can do a similar thing. Let's return to equations 1 and 2. Let's subtract equation 2 from 1 this time around. If I do that, so I'm just going to erase these positive signs. So if I choose to subtract equation 2 from equation 1, the left side is going to be sine A plus B, then the negative sign, then sine A minus B, sine A minus B. So let's focus on the right. Now, here is a negative sign here. Sine A cos B minus sine A cos B. That's gone. Then cos A sine B minus cos A sine B. So the minus minus becomes plus. So that becomes cos A sine B plus cos A sine B. And that's equal to 2 cos A sine B. This is the third product. This is cos A sine B, 2 cos A sine B. That's a product. So we can see that 2 cos A sine B is equal to sine A plus B within parentheses minus sine A minus B within parentheses. So the fourth one, I'm going to do a similar thing, but this time around, I will be focusing on equations 3 and 4. If I choose to subtract equation 4 from 3, then the left side will become cos A plus B, then the minus sign, minus cos A minus B, right here, cos A minus B. So the right side of it, we've got cos A cos B. Of course, there is a minus sign, minus cos A cos B. That's gone. Then here, minus sine A sine B, minus plus is minus. So this is just minus sine A sine B, minus sine A sine B. And that's going to be minus 2 sine A sine B. This is the fourth product. negative 2 sine A sine B is equal to cos A plus B within brackets minus cos A minus B within brackets. These are the 4 products we're going to be focusing on. The next thing is going to be to use this product to solve 1 or 2 problems. These are the examples. The first one, we're asked to express sine 75 minus sine 15 as a product. This case involves the conversion from a difference. This is a difference, a subtraction, from a difference to a product. And not just a difference, it's a difference of signs. This is sine 75 minus sine 15. So we just have to check these 4 formulas and see. So this tallies very much with equation 3. This is a difference of signs, and of course, it always gives 2 cos A sine B. So what we just have to do is we have to reproduce this formula. So this looks very much like, as we can see here, this is a difference of signs, just as we have here, sine 75 minus sine 15, and it always gives this product, 2 cos A sine B. So all we just have to do is to compare. Comparing, we would see that A plus B is 75 by comparison. A plus B is 75, and also A minus B is 15. We can see that clearly. A minus B is 15. So if we had these 2 equations, I'm going to call this equation 1 and this equation 2. Adding these 2 equations, this is going to give 2A, that's the left side, equals B is gone because B minus B is just 0. 75 plus 15, that's equal to 90. Dividing both sides by 2, A is 90 over 2, and this is 45 degrees. And if I also choose to subtract the second equation from the first, of course, that's going to give A minus A, that's gone. So this is B minus minus B, that's B plus B. And that's 2B equals 75 minus 15, that's 60. And this fetches, of course, B equals 60 over 2, that's 30 degrees. What this tells us is that sine 75 minus sine 15, this is a difference, is equal to 2 cos A, and in this case A is 45, so this is 2 cos 45 sine B sine 30. In question 2, we are to express the following as a sum or difference. So this is 2i right here. The first one is sine x cos 5x. Now we are moving from a product to either a sum or a difference. So what we just have to do here is compare. So we've got a sine cos. So we just have to return to these formulas. Now we are going to be focusing on the right side. Wherever we've got a sine and a cos, so it's obvious that it's the first one. Sine A plus B plus sine A minus B is equal to 2 sine A cos B. So I'm going to reproduce this formula. Now if I divide this expression, this equation, if I divide both sides by 2, I would have, now I've got sine x cos 5x. So comparing sine x cos 5x with sine A cos B, it's obvious that A is x and B is 5x. Therefore, sine x cos 5x is going to be equal to 1/2 sine A plus B, that's x plus 5x, plus, we've got a sign here, then A minus B, that's x minus 5x, so this is x minus 5x, I've run out of space, x minus 5x, okay, so this is equal to 1/2 x plus 5x, that's 6x, plus x minus 5x, so this is sine, this is a negative 4x, so this is equal to 1/2 sine 6x. Now sine is an odd function, and we know that a function is an odd function if f of negative x equals negative f of x. Therefore, sine negative 4x is negative sine 4x. This is our final answer. Sine x cos 5x, which is a product, is equal to 1/2 sine 6x minus sine 4x, and this is a difference. Of course, this can be written as 1/2 sine 6x minus 1/2 sine 4. I'm going to leave you to work on the second one. You could call it classwork, internet work, YouTube work, whatever works for you. So just try it out. It makes lots of sense. This is -2 sine 45 sine 15. So if you want to compare, just compare it with the one that has a -2 sine A sine B, and that should lead you to your destination. In summary, we can see that these two formulas here, these two, show a relationship between the sums and the products. We can see that these are positive signs, and the last two shows a relationship between the difference and the product. Thank you for watching this video. If you find it useful, kindly like it by giving it a thumbs up, share to your friends and colleagues on social media. Don't forget to drop a comment and click on the subscribed icon. To get notified when I upload new videos, kindly click on the all, that's the dark bell button on the subscribed icon. Thank you for seeing it once again. See you in the next video.